Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to do part one of an Algebra 1 spiral review. Gosh, I can speak, I promise. This is I think, 3 or 4 part series of what a student sent in on spiral review. Some of these things are logarithmic and exponential functions. These are problems that the student got wrong from the review sheet that they're getting ready for a test. So without further ado, let's go ahead and let's get started. Let me just change my ink color. Beautiful. Okay. So ideally what we're doing is when we have a problem like this where we have to solve, we need to create something where something is exactly the same so we can kind of disregard it completely. And then we can go ahead and compare the things that are different. I'm actually going to start with problem 2 because it's a similar type of problem to show you what I mean by finding something exactly the same so that we can then go in and kind of disregard it altogether. So in this case, I have the natural log of 2 things. That is exactly the same. So what I can do is I can completely disregard that and just take this x plus 2 and set it equal to 2x minus 1 and call it good. And that's going to be my method of solving a lot of these problems that say solve that have 2 things on two different sides of the equation. So I'm going to go ahead and subtract x from both sides, add 1 to both sides, and I'm going to end up with x is 3. Final answer, not doing anything else with this. In this particular case, because I have 2 different bases, what I want to do is I want to find the same base. So I know 25 is 5 to the second, and 125 is 5 to the third. So all I can do is I can take this 5 to the second and get 2x plus 1 as an exponent, and 5 to the third and get this 3x minus 7. And I now know that I have 5 and 5, which is exactly the same, so I can disregard those. But then my exponents kind of just get multiplied, right? So I'm going to end up doing 2 times 2x plus 1, whoops, and 3 times this 3x minus 7. I'm going to go ahead and distribute, get 4x plus 2 equals 9x minus 21. Subtract 4x, add 21. I'm going to end up with 23 equals 5x. I feel like I've done something wrong, but I don't know what it is. So let's think about this for a hot second. Yeah, no, so far so good. So x is just going to be 23/5, which is a little bit gross, but I mean, that is what it is. It's algebra 2. Algebra 2 numbers are pretty gross. In this particular case, we don't quite have something on both sides that are going to be the same so that we can disregard it. But we do have this log base 2 for both of these problems. And we know that when we add in order to condense versus expand, when we condense and we have an addition problem, we know we're going to multiply. So technically, this is just going to be log base 2 of x minus 2 times x, which equals 3. I can go ahead and multiply this out. So I'm going to end up with log base 2 of x squared minus 2x equals 3. And then what I do is I just call it to it, but it's not what it's called. It's called something fancier, I'm sure. Is I'm just going to take 2 to the, like, as a base so that I can eliminate this as a property of logarithmic functions, right? So I can then go in and I can just say, hey, x squared minus 2x equals 8 because 2 to the third is 8. And then I'm going to go x squared minus 2x minus 8 equals 0. And then I'm going to solve by factoring, and I get minus 4 plus 2. And so x equals 4 and negative 2. Now, in this particular case, x cannot equal negative 2 because I can't have log base 2 of a negative number. We really can't have log of a negative number. So we're going to reject that negative answer and say that x only equals 4. Whenever they have an equation where it says solve, you always want to be careful with those negative numbers. I have come across some teachers who say you absolutely cannot have a negative answer. Even if it does work out, we don't accept negative answers. I've had teachers who do accept negative answers. So basically pay attention to what your teacher is saying and then kind of do what they do. There is there are math fights in math in the math circle about how certain math should be taught. So just bear that in mind. Okay. When we are looking for the inverse of a function, the first step that we will always take is replace the x and the y. So I'm going to start off with x equals, and I'm going to start on this side so that way I have some more room. And I know that when there's no base for a log, I'm going to say that it's base 10. And so I can use my properties of logs and just 10 this whole business so that this will cross out. So I'm going to end up with 10 to the x power equals this y plus 2. And then I can subtract 2 on both sides and I get y equals 10 to the x minus 2, like as a whole number, minus 2. And then that would be my final answer. So you're always, when you're looking for an inverse, step one is make sure you're replacing the x and y, and step two is get y by itself. Okay, so in this particular case, I don't know why it says borrowed. Let's just change that because it's gonna bother me. Okay, so you borrow $10,000 from your uncle to buy a car. He agrees, but charges you 3.6% interest, compounded monthly. Okay, that's kind of important. 3.6% interest is important, the amount of money that you borrow. Exactly 3 years later, you sell the car for $10,000. Okay, if you have made no other payments, not other payments, no other payments, how much money do you still owe? Okay, so my assumption is you're borrowing. That's an interesting question. Okay, let's take a look and let's figure out how much are you paying over the course of 3 years. Okay, so we don't know how much we're paying over the course of 3 years, but we know that we've borrowed $10,000. Let me actually get my calculator handy because I know that math is not going to be done in my head. We're going to multiply it by 1 plus the rate. So the rate is this right here. So 3.6, which is the same thing. So if I take 3.6% and turn it into a decimal, it's going to be 0.036. So I'm going to go 0.036. N stands for the amount of years. Sorry, the amount that has been compounded, right? So in this particular case, I'm compounding monthly every year. So if I compound monthly every year, that means I'm going to have 12 payments. So I'm going to go 12. And this is going to be 12 times 3 because T stands for time in years. So that's that. I have one of these calculators. It's not fancy at all. I think it's like maybe $10 at Target is where I got it from. I do have other calculators that students prefer, but this is my favorite. And the way that you put things in on this calculator is a little bit different than other calculators. The ones that have like the double row screen, that you can just put this information in as is and push equals and you'll get an answer. This one you kind of have to work a little bit backwards. So you're going to go 0.036 divided by 12. Then you're going to go ahead and add 1. And then you're going to push the YX button and do it to the 36th power. And all of that is going to equal some really big number, but it essentially is 1.1138, blah, 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 blah. Okay. And then you're going to multiply that by 10,000. 10,000, so many zeros equals, okay. I don't know why I did that part on a calculator. That was just moving the decimal over. That was silly. Okay. 67. So this is how much money you are paying over the course of 3 years with this interest rate. Now, when you sell your car for 11 grand, technically the difference between these two dollar amounts. My thought is the question is asked a little bit funny. But I imagine that the question was, hey, like you've made 11,000, how much have you paid? And like what's the difference between the amount of the sale and the amount that you've paid for this car? I would imagine that this would be the answer to this problem. I just think it's worded a little bit in a way that I don't quite understand. Okay, and then the last question in this particular page is to simplify. So we know we cannot have a radical in the denominator. A radical in the denominator means that we have a negative exponent. Um, in order for us to not have a negative exponent, what we're going to do is we're going to eliminate this radical. So if this was just radical 3 in the denominator, I would just multiply by radical 3. That is a weird looking radical sign. But because I have this fancy pants entire expression, I'm going to multiply by the conjugal pair. So a conjugal pair is just something that will create like the difference of two squares, right? So this is kind of like the difference of two squares where the first term and the last term is the same. And the only difference is this positive negative business, right? So the 20, I'm just going to distribute to everything. And then here, I'm going to multiply the 5 by the 5, the root 3 by the root 3, and then put a subtraction sign in the middle. So 5 times 5 is 25, root 3 times root 3 is 3, and then I'm going to just subtract in the middle. And then this will be 100 minus 20 root 3. I can then go in and do the math here. So 100 minus 20 root 3. I know that I can't do anything with this because these are different types of terms. And then this will become 22. So I do know that I can simplify all three terms because they're all divisible by 2. So I'm just going to divide all of them by 2 and get 50 minus 10 root 3 over 11. And then that would be my final answer altogether. I hope that this video was helpful, and I will see you in part 2 shortly.